All right, everybody, let's get started. Welcome to session DAT 309, Best Practices for Migrating from Oracle and SQL Server to Amazon RDS. My name is Kevin Jernigan. I'm a product manager working on Aurora Postgres, and I'm working today with John Winford, who's a product manager in the AWS Database Services team, who spends a lot of his time on database migrations. And John's going to come up a little later, the second part of this session. So first off, thanks for taking your time in your busy reInvent schedules to come to this session, especially Monday at 7 o'clock. Actually excited to see how many people are here. I didn't expect this many at this hour.
Sorry, that's going to be me.
All right. Now I'm off. Okay, now I'm back. Okay. But I'd like to get a feel for who's here and kind of your use of databases. So I'd like to see a show of hands. First off, who here is using Microsoft SQL Server? Wow, a lot of SQL Server users. Okay. And who here is using Oracle? I guess I should ask, who here is using both? Yeah, okay. Yeah. Maybe not too much of a surprise. Okay, and now different databases. Who's using MySQL? Okay. And finally, of course, who's using Postgres? All right. Database, really? No, we're not going to go that far back in the past. All right, so I have a feel for who's here and what kinds of databases you're using. And I'll try to leave time at the end for questions specific to your migration scenarios from all these different databases to all your different favorite targets. But what we plan to cover today is to, first off, just talk about what RDS is, Amazon Relational Database Service. I'm not going to spend a lot of time on that, but just want to give a brief overview. And then I'll talk about homogeneous migrations from Oracle and SQL Server on premises or on EC2 to their RDS equivalents. And then we'll dive into the possibilities of migrating those databases to other databases, such as MySQL or Postgres or Amazon Aurora. And then John will take over and he'll dive into how to use AWS Database Migration Service, Schema Conversion Tool, and related services to help do those migrations. And then, of course, we'll wrap up with a look at some detailed best practices, and of course, we'll get into some Q&A. So before we get into all these nitty-gritty details, let's talk about migrating databases to AWS from on-premises environments. And the first question to answer is, well, why migrate databases to the cloud in the first place? And our customers have helped us answer this question in lots of different ways over the years. And their answers generally fall into these three categories. They want to reduce costs by moving their IT costs from CapEx, from buying and maintaining hardware and software and data center, power, space, and cooling, et cetera, to OpEx, where you pay as you go. You pay for what you use rather than purchasing for peak usage and carrying that cost the whole time. Customers also want to simplify operations by moving the responsibility for maintaining data centers and servers and networking and storage and software as much as possible to AWS, to us. And they want to increase flexibility and agility by freeing themselves up to focus on what's core for their companies, for their businesses, and for their customers, rather than spending time on all that boring stuff. But the previous slide really just scratches the surface of the benefits of moving your databases to AWS. With Amazon Relational Database Service, RDS, we take things a big step further by automating most of the boring, repetitive, day-to-day drudgery of running relational databases. This means RDS automatically monitors your database instances and will replace or recover an instance which fails due to software or hardware failures. And RDS will automatically take backups of your databases and retain those backups for up to 35 days. That's up to you how long we retain backups. RDS can also provide automatic and transparent high availability with RDS Multi-AZ, which when enabled will automatically create a second copy of your database in a separate availability zone and keep it in sync with your primary database with synchronous replication. And RDS provides these benefits for multiple database engines, including MySQL, Postgres, Oracle, SQL Server, MariaDB, and Amazon Aurora. Now, to help visualize the benefits of moving your databases to Amazon RDS, let's look at the stack of activities you're responsible for when running your databases on premises. This stack includes everything from the basics of data centers, power, space, cooling, racks of servers and storage and networking gear, and then installing and maintaining the software and the firmware on each device and ensuring they're kept in sync with each other for compatibility, and ensuring you have the latest patches installed to protect against security vulnerabilities, and so on up the stack through higher level responsibilities, such as taking database backups and setting up and maintaining replication for scale out and high availability, and last but not least, working with your application development teams to ensure they're building apps that make optimal use of your database infrastructure and ensuring that you are providing the database infrastructure they need to move fast. That looks and feels like a lot to do, and not very much of this picture is core and unique to your business, is it? And so if you decide, well, great, I want to move my databases into AWS, you might decide to move them onto EC2, where you'll provision some EC2 compute instances, provision some storage from EBS, and you'll install some database software and you'll manage it yourself. And that will save you some of that boring drudgery, all the stuff that's moved over to the right on this slide. So, managing the data center side of things, you've now moved onto AWS. But you're still responsible for all that stuff on the left. The OS patches and installing database software and patching database software and doing backups and setting up replication and HA and DR and all that other fun stuff. And oh, by the way, you still have to work with the application teams too. So if you move your databases into Amazon RDS, you move almost everything over to the right, over to AWS. And you're left with the stuff that's the most important thing for you and your customers. Application optimization, optimizing your database infrastructure to run your applications in the best way possible and give your application development teams the best environments in which to innovate and to grow your apps. So now let's talk about homogeneous migrations. Let's say you're running Oracle or Microsoft SQL Server on premises, and you're excited about all these benefits I just covered, and you want to migrate to Amazon RDS to move into the cloud. You have lots of choices, as you probably realized. You can move your databases to self-managed EC2, like we just talked about. You can move your databases to Amazon RDS for Oracle or RDS for SQL Server, or you can migrate from Oracle or SQL Server to MySQL Postgres or the MySQL or Postgres compatible editions of Amazon Aurora. And of course, you can mix and match your strategy. So you don't need to move all of your databases to one target. You can separate things out and you have lots of different choices. But let's say you choose the simplest path first and you decide to migrate your on-premises Oracle or SQL Server databases to self-managed EC2 hosted databases. In that scenario, you can move your data using the native tools available with each database engine, including backfile import for SQL Server, or various tools including SQL Developer, Data Pump, Import-Export, RMAN backups, et cetera, for Oracle. And note that RMAN backups can't be used to migrate into RDS for Oracle, but you can move them, use them to migrate into Oracle on EC2. And of course, if you're running MySQL or Postgres on premises, then you can use tools native to those database engines to move into self-managed on EC2. Or you can use read replicas to migrate MySQL into RDS for MySQL and pgdump and pgrestore, Postgres-specific tools, to migrate Postgres into RDS for Postgres. Now, I've talked about the benefits of using RDS to manage your databases for all the engines supported in RDS, but what about the benefits specific to Oracle and SQL Server? The major areas supported by RDS are listed on this slide. They include the same benefits as for all the engines: fast provisioning, built-in security, easy configuration of high availability, and easy scaling of both storage and compute. And for both engines, we also support bring your own license or BYOL and license included licensing models, and of course, specific releases and additions for both engines. Now, some more specifics on RDS for Oracle. Some recently shipped features for RDS for Oracle include support for the latest release of Oracle Enterprise Manager, support for Oracle Spatial and Apex version 5, support for more instance types to give you more flexibility in compute and memory capacities, and support for up to 16 terabytes of storage, up from the previous RDS limit of 6 terabytes. Now for SQL Server, we've recently shipped support for forced SSL, which allows you to force all connections to be secure to use SSL. We've also added inclusion in our BAA to allow you to use RDS for SQL Server in HIPAA-compliant environments. And note that now all RDS engines, including both Aurora engines, are now part of the BAA, and so therefore all RDS engines are eligible for HIPAA-compliant environments. We've also done expansion of the regions where you can provision SQL Server Enterprise Edition, and we've added storage scaling up to 16 terabytes. The previous limit for SQL Server was 4 terabytes, and we've added support for more instance types. So we're continuing to add more capabilities for both RDS for Oracle and RDS SQL Server inside the RDS environments. Now, I've talked about some of the capabilities of RDS for Oracle and SQL Server, and in a few minutes, John is going to dive into deeper details on how to migrate from those databases on-premises into RDS. But before we go there, I want to talk about heterogeneous migrations, moving from Oracle and SQL Server to open source databases in RDS, including both the standard open source engines and the Amazon Aurora engines. And the first question to answer is, why migrate from Oracle or SQL Server to open source? Isn't that a lot of work? You know, don't I have to change my schemas and my data, and my stored procedures, and my app code, and my triggers, and my operational procedures, and all that stuff? And the answer is yes, it can be a lot of work, but many customers are very motivated to go through that transition for a variety of reasons, including the need to reduce licensing costs. Oracle and SQL Server are good database engines, but they are very expensive. And customers are always looking for ways to reduce costs. And replacing expensive commercial database license with open source engines which have no licensing costs is a compelling opportunity for many customers. But what many customers find even more compelling is moving from on-premises traditional legacy databases to cloud-optimized open source databases. They see opportunities to rethink and re-architect their monolithic on-premises apps to take advantage of the wide range of data processing and data management capabilities in AWS, where we've optimized different services for different use cases. And the RDS open source engines, especially Aurora, are engineered to make it easy for you to start that journey towards a more nimble, more flexible, and more agile environment. So a brief history of MySQL, a little more detail about where MySQL came from and why our customers love both of the MySQL services, RDS for MySQL and Aurora MySQL. Most people recognize MySQL as the most commonly used relational database out there, given its prominence in the LAMP stack that became popular starting in the late 1990s, where the M in LAMP, of course, stands for MySQL, and it's Linux and Apache and Python as the other letters in the acronym. And so MySQL was the first engine we launched with RDS back in 2009. Now, there are multiple variants today, popular variants, including MariaDB, which we also support in RDS, and Aurora MySQL, and I'll talk a little bit more about Aurora in a couple minutes. Now, for Postgres, it's a different history. Postgres was started in 1996 as the outgrowth of essentially a graduate research project at UC Berkeley. And unlike MySQL, Postgres is not owned by a company. You can't buy a company and get control of Postgres. The Postgres Foundation, nonprofit foundation, manages the community that develops and supports Postgres. And the license used by Postgres encourages innovation and extensions and forks, so much so that the PostgreSQL.org website lists 44 forks as of yesterday. And I know that list is by no means complete. Now, at the same time, the core community has remained very focused on code quality. And Postgres has a reputation as being very stable and delivering high performance out of the box for most database workloads. Now, in addition, Postgres provides the most ANSI SQL compatible implementation of SQL, of any relational database you'll find, and also has really deep and rich support for geospatial capabilities. So any kind of IoT-related application does really well with Postgres. And also supports stored procedures in multiple languages, including PL/PG SQL, which is very similar to Oracle's PL SQL. And the bottom line for a lot of these capabilities is that many customers have told us that when they look at which open source database they want to move their Oracle or SQL Server workloads to, they find that they usually choose Postgres because it's the most consistently close database to Oracle in terms of semantics and transactional model and the MVCC model and et cetera. Now that's what customers tell us kind of as anecdotes. We also see that in the data produced by the schema conversion tool, which is part of the AWS Database Migration Service John will talk about in a minute. But customers can use SET to automatically assess how much work it will take to migrate from a given source to a given target database. SET shows the highest automatic conversion rates for an Oracle and SQL Server database when you target Postgres as the landing point. So we have data to back up the anecdotes. Now, I've mentioned Amazon Aurora a few times in this session. I want to give you a very brief tour of Amazon Aurora to help you understand why customers have made it the fastest growing service in the history of AWS, and why we've doubled down on Aurora by adding Postgres compatibility. So like almost everything we do, Amazon Aurora was born out of customer demand and customer feedback. In using RDS, remember back in 2009 we started with MySQL, customers got accustomed to seeing both commercial and open source databases side by side in a managed database environment. And they started asking for the best of both worlds. They want the speed and capabilities of commercial databases combined with the low cost and simplicity of open source. And so this caused us to eventually, after we listened for a while, caused us to rethink how relational databases are built and to focus on re-implementing the caching and the logging and the storage layers for the cloud for AWS. Now we did this initially for MySQL, launching the MySQL compatible edition of Amazon Aurora in July 2015 with up to 5 times the throughput of standard MySQL at 1/10 the cost of commercial database engines. Now, the core of Aurora is the Aurora Storage Engine, which is a distributed, massively parallel, log-based, and database-aware storage system. That's kind of a big mouthful. I say distributed because it's distributed across 3 availability zones. It's massively parallel because a typical Aurora storage cluster will have hundreds or sometimes thousands of storage nodes in it. It's log-based, which means we only ever write log records into the storage system. And it's database-aware, which means we've taught the storage system the format of those log records and the format of database pages for MySQL and now Postgres. That allows us to do all kinds of fancy things, including improving performance by up to 3x for Postgres and up to 5x for MySQL. It also allows us to support up to 15 read nodes attached to the same storage volume spread across 3 availability zones and provide failover times of 30 seconds or less to those read nodes. Now, both the storage layer and the database instance layers are monitored and managed automatically, just like normal RDS engines, to ensure that the failure of disks or storage nodes or database instances or other components are automatically recovered from without requiring manual intervention by the end user. Now, we've recently added Postgres compatible edition to Amazon Aurora. We went GA on October 24th in 4 AWS regions, and we've added 4 more regions just last week. Now, both editions provide the same benefits: higher performance, fast failover, read scale out, and dynamic and automatic storage scaling up to 64 terabytes, all with full compatibility with MySQL and with Postgres. And many customers are choosing to migrate their commercial databases to the Aurora database engines because of this combination of commercial database level performance and durability and high availability, together with the low costs of open source and the compatibility offered by MySQL and Postgres for their workloads. So I'm now going to ask John Winford to take over. He will review how to use the AWS Database Migration Service to migrate your databases and talk through some of the scenarios related to that.
Thanks, Kevin. Hopefully everyone's learned some stuff so far. I myself have learned not to walk in front of a speaker with a live mic. Hopefully I don't make that mistake again. But yeah, I'm here to talk a little bit about database migrations and also run a bit of a demo to show you guys actually how it works. So I'm just unlocking my computer. We'll get to that in a few minutes. But before that, we'll do a bit of a background on how we do database migrations at AWS. So at AWS, we're all about being responsive to customers. For many years, customers were like, great, you've got this great managed database software called RDS. Well, how do I actually migrate to the cloud? How do we make it easy? How do we make it less intrusive for our end users? You know, it's one thing to say that I can do a database migration and, it'll all work, but if you read the fine print somewhere in there, somebody said you need to take a 2-week outage. I mean, that's just not really feasible. As part of those migrations, people wanted to have some flexibility. Either I stick with the same database engine that I'm running, or maybe I want to go to use something else. And then once that migration happened, what are our options? How can we do ongoing synchronization? How can we sync between on-prem and the cloud? Is that kind of thing possible? And it's this mobility between different engines, different locations, that brings us to one of the biggest requests. That is the ability to migrate off commercial license-intensive engines onto cloud-native open source solutions. And those are the solutions that Kevin was mainly talking about. So he's done a bit of an introduction to DMS and SCT. DMS and SCT are AWS's solutions to database migration. DMS is what moves the data. SCT is what moves the schema. So they're very closely related cousins. You use SCT first to move your schema, and then DMS to move your data. You can see to this point we've moved over 45,000 unique customer databases with the products since we launched. There's some minute details in there. SCT, actually, you use it to move your data as well for data warehouses, but I'll talk a little bit more about that later. It's also important to note, as Kevin mentioned early in the slide, that there are other solutions for your migration as well. If you're doing a homogeneous migration, that is, you're sticking with the same database engine, DMS and SCT can definitely help, but there might be a better solution for you out there. So just go in there with your eyes open, evaluate the scenario you're trying to do, and use the best tool. So, in particular, when should you use it? A little bit more detail on a similar slide Kevin had earlier. DMS can help you do 3 things. They can help you modernize, migrate, and replicate. So migrate's the obvious one. You're looking to migrate from on-prem to the cloud, or maybe you're doing something like moving data from your transactional online system to a data warehouse. People have used it for some other neat things, like upgrading minor versions. With RDS, you can upgrade your database version with a click, so go from, say, 9.3 to 9.4, but it does still have an outage of about 4 minutes. For some people, 4 minutes is too long, so you can use DMS to actually spin up a newer version of a database engine and migrate the data across with essentially 0 downtime, just as long as it takes you to update a DNS entry. It can be used for ongoing replication. So people tend to use it for things like synchronizing data into a data warehouse. Other people use it for a DR type scenario, or where cross-region replication isn't available natively. DMS can move data from anywhere to anywhere else. It doesn't matter if that anywhere else is in a different availability zone, a different region, or possibly from AWS back to your on-premise system. DMS can do that. But its key power is to help modernize your engine. So if you're looking at moving from a commercial engine to an open source engine, DMS is your friend. It will definitely help you migrate your data between the 2 systems.
When it replicates, is it incremental or is it a full replication?
No, it's incremental. We'll get to it in a few more minutes, how DMS does what we call change data capture, but we basically read the logs and get the changes as it goes across. So again, just reiterating, DMS, you use it to migrate applications. You can go from Classic to Amazon VPC. If anybody's been using AWS for quite a while, you know we changed our networking infrastructure a while back, so that can help you move between versions. You can do shard consolidation, another really popular thing. So unlike Aurora, MySQL doesn't scale out very well. So people have quite often used shards, so essentially multiple MySQL instances. If you realize now that with Aurora, due to its better storage and better performance, you can move all those shards into one single instance and save money as part of the process, DMS is your tool to help do that. It can also help you go from SQL to NoSQL or vice versa. So we've had a fair bit of interest of people that have gone down that NoSQL path for databases that maybe shouldn't have been NoSQL and use DMS to get back to the relational side of the fence. And then, of course, vice versa. Lots of people have used it to migrate information to DynamoDB. It's actually, just forgot to mention, something that only came into effect a couple weeks ago. As far as costs go for DMS, DMS is actually free if you are going to the open source engines. So you're looking to go into Aurora or to Dynamo, there's no cost for DMS in there to Aurora, Redshift, and Dynamo targets. So that's just one thing to help incentivize your migrations. That's something new that was just launched in the last couple weeks. So when do you use SCT? As I said, SCT is all about converting your database schema. So step 1 of your migration, convert your schema. Step 2, move your data. But it can also help move your data warehouses. So data warehouses are a bit of a different beast. We don't have an ongoing replication solution for warehouses because generally speaking, these are things that are created as part of batch jobs, have nightly processes, that sort of thing. So SCT can actually do a dump of that data. It does a dump out into essentially what is Redshift native format, which of course gets ingested in via S3. But what's also new with SCT is some direct integration with Snowball. So if you have really big data sets, these are data sets that are, say, above the 10 terabyte size, or you have a whole fleet of databases you want to move to the cloud, SCT can now help move all that data onto a Snowball, spin up a DMS task to keep track of any changes, while that Snowball gets shipped via FedEx to the cloud, and then ingested in to AWS, and then DMS will apply any changes that happened while that Snowball has been in transit. We have a session on Thursday that goes into that in a bit more detail. In fact, there's sort of a demo, if you will, with some recording showing how it all happens and some live Snowball integration. So if you're interested in how you do these really big migrations, do come along. It's also important to note that DMS actually does not have any size limitations. So there's nothing saying when you need to use a Snowball versus when you don't, but people tend to stick in sort of the 5 terabyte max time to do a migration with DMS purely because how long are you really willing to wait for data to move over an internet connection? So in summary, when do you use DMS and SCT? You're looking to have a near zero downtime migration, allow database freedom, moving between engines, and of course it's very cost effective. As I said, it's downright free for some targets, and it's literally on the cost of dollars to move for the others. It's a pretty minimal cost service. So there were some questions on how DMS works. That's what we're going to talk about first. I know I've said it about 3 times already, so I'm going to just go pretty quick. Your database migration process, step 1, move your schema with SCT. Step 2, move your data with DMS. SCT, to get into a bit more detail, it converts that schema. It'll also convert a data warehouse schema. It'll also convert application SQL. So if you have a bunch of procedures or views or what have you written with a lot of PLSQL, SCT will actually automatically convert it. It will scan your database, and it will give you an estimate as to what percentage of your schema it can convert automatically, and then compare between different database targets, which is likely to achieve a higher conversion success rate. It's a bit different for an Amazon product. It's actually a client tool. It's a free download off our website. There's no cost at all to use SCT. It's available for your operating system of choice. It can help you convert your schema, or interestingly, it can also help analyze your existing database from a licensing perspective. So say you just got to stick with Oracle for whatever reason. What SCT will do, it will look at what you're using from Oracle and give you a recommendation going, hey, look, if you did migrate to the cloud, you could possibly go from an enterprise license down to standard edition or something like that. So it looks at your existing licensing and says what are your options out there. But of course, its primary goal is to give you a bit of insight as to what it would take to convert to an open source platform. Here's that assessment report that we mentioned. Essentially, it gives you a nice executive summary at the top, something to just, your 1 paragraph to send off to the boss and go, hey, look, this is sort of what we're thinking. And down below, you get some bar charts telling you for the different components of your schema, your tables, your procedures, your triggers, what have you, what percentage are going to get converted automatically. And it does this for every of the available targets. So it'll be a section of the report for MySQL, a section of the report for Aurora, and a section of the report for Postgres. And it does that for any of the engines that it works with. A little bit more detail, you'll see this in action in a few minutes when I do my demo. It's essentially an integrated development environment. So anybody that's used any other IDE, you're going to feel pretty much at home. The idea being you launch your client, you connect your database. On the left is your source schema, on the right is your target schema, and in between are the objects that you're working with at the present time to do the conversion. So, how does DMS work? I alluded to it earlier, but we'll get into the details now. If you assume what you're seeing up on the screen is a migration, I know it says customer premise on the left and AWS on the right. just think of it more as source and target, because if you actually wanted to move from AWS back to on-premise, you could do that. So to contradict anything that some of the competitors say, we don't believe in vendor lock-in. You can use our own tools to move back out of AWS if you want to. It's not something we see very often, but you can do it. So you could be moving from an EC2 instance to an RDS instance, from RDS back to EC2, or of course the more obvious thing is from on-premise to the cloud. So lots of options, just look at it as source and target. The only thing you can't do with DMS is an on-premise to an on-premise migration. So you kick off by launching a replication instance. This replication instance is in essence just an EC2 box with our replication software installed on it. You never log on to the box yourself. We fully manage it for you. You interact with it through the console, API, or SDK. Everything with DMS is fully API driven. There are actually more features and knobs available if you use the API versus even the console. You'll find that's a pretty standard trait across AWS services. We're very service driven as opposed to GUI driven. So just know that everything you can do through the console, you can definitely do through programmatic methods, which becomes very handy if you have a mass database migration with a lot of similar databases to move. Once that instance is launched, you define your connections. So your connections are essentially an ODBC connection string to your source and to your target. One replication instance can have many different sources, many different targets, and many different replication jobs. It's just a processor, like a big CPU for migrations, so you can use one box to do many things or just one thing. You've got these connections defined, then you say which tables, schemas, or databases you want to move. DMS is a logical replication tool. That means we don't just say grab the whole database, we can grab certain tables, certain schemas, or down to certain records. You can say, look, I only want to grab the records from the last 5 years out of the table, and it can pull that across. Once you've selected what it is you want to move, you sit back, relax, and watch DMS move the data across, and optionally, if you've enabled it, it will read the transactions that happen during the migration to allow you to get those two databases in sync to the point that your customers, or rather your users of the database, don't even know the migration is happening, and at some point you take a small outage, update your applications to point from your old database to your new database, and you're done. So it is very much a minimal downtime migration product. A bit more detail as to how it does it. Behind the scenes, every database has logs. We are literally using the native APIs that those database engines make available to read the transactions from the log, funnel them through the replication instance, and apply them to your target once the first step of the migration, what we call the bulk load, is complete. So when the bulk load is there, we bring across the transactions, and it happens on a table-by-table manner. So if you've got 10 tables you're migrating, or 1,000, doesn't really matter. Once the first table makes it to your target, we start replicating the changes across for that table as we're working on the load for the second table, so on and so forth. Reality is a lot of it happens in parallel, but that's the general idea. What this does require is for you to enable logging on your source database. So with Oracle, that's supplemental logging. With MySQL, that's row-level bin logging, and so on and so forth for all the other engines. What's really good about this solution, though, is we don't need any agent installed on your source system. We literally reach out through the connection and get the information back from the API. What this does mean, though, is we don't work with some really old database engines that don't have these APIs. So if you're running something from circa 2000, we're probably not going to be able to pull those transactions across for CDC. So that's been a lot of talking, a lot of slides. I'm sure everyone's seen a lot of slides today. It's probably time we get into a bit of a demo and show you how this thing actually works. So, providing technology behaves for me here, I'm just going to press the magic button, and hopefully we get my laptop up on the screen. Look at that. All right, so this is a live demo. This is not some pre-recorded thing. What this means is anything can go wrong at any time, but that just becomes entertainment for you guys. So that's good. We're going to go through, and the idea is, of course, that we're going to do a very simple migration from Oracle to Aurora. Kevin spoke a fair bit about Aurora today, so I figured that was a good target. We'll show actually how to do this migration, and then once it wraps up, we're going to dive into some of the best practices on how you actually do it. So here we are. This is my an EC2 box I have running up in the AWS cloud. Again, doesn't matter the operating system you decide to use. I've just got this running here. And we're going to kick off by showing some of the basics. So I'm just going to use this open source product I have called dbeaver. Again, use any query tool you want. Rather amusingly, a new version came out today, but thankfully it's not prompting me to install it right now. But the reason I use this product is you can see I've got connections made to a whole range of different database engines, right? So I've got MySQL, Postgres, SQL Server, Oracle, you name it, it's all there. So the first thing to show, just to make sure there's no smoke and mirrors here, I'm going to connect to my Aurora Postgres destination. And you can see in here, I really don't have anything. It's an empty database, just a few default schemas created there. Nothing really, well, it's empty. So we're going to actually move some data in here. My Oracle source in this case is just down below. I've got a number of different schemas. We're going to look at moving across the Chinook schema. So some of you guys may have heard of the Chinook schema. It's just a common demo database that's available out there on the internet. Has a few tables in it. I believe the general idea is it's some online music type database where you can purchase your latest MP3. What I have here is just for your own interest's sake, there's the relationship diagram between all the different tables. So that's the idea of what we're going to try to move. Now, it's currently in Oracle. We're looking to move it across to Postgres, or Aurora Postgres in particular. So we're going to convert this schema into an Aurora schema as part of this demo. So the first thing we do is launch the schema conversion tool. As I mentioned earlier, the schema conversion tool is a free download from our website. So I'll just kick that off. Fires up. Now, here it is. This is the IDE. It's not too amazing to look at, but it does some pretty cool stuff behind the scenes. I'm just going to kick off and do a new project. And let's do Oracle to Postgres. So I'm going to choose my targets here. As you can see, I can choose between a transactional database or a data warehouse. Actually, you know what? I'm going to start with the wizard. The wizard's always a better way to do these things. New project wizard. That way, it's like you don't know which engine you're going to use. You're making a decision. So similar kind of thing. I know my source is Oracle. I don't know what my destination is yet. Remember I mentioned that you can use this to optimize your licensing. This is where this second option comes in. It'll look at your licenses and give you some recommendations here. So I can hit next. I'm going to connect to my database. Now you guys are going to laugh at this because it's like super secure, me having my password and text file on the desktop, but it is just a sample database. If you want to go mess with it, I really don't care. Here we go. I'm going to connect to my RDS instance, hit next. So it's going to scan the database, looks at everything that's in here, and I'm going to say which schema do I want to analyze. In this case, I know we're going to look at Chinook later, but I'm going to be honest, Chinook is a pretty simple schema. Let's just have a look at the DB master schema because it's a bit more interesting. I'll just do a quick scan of it. It's looking at everything in the schema from those procedures to the triggers, the packages, what have you. Goes through everything and then pops up on the screen this thing called the assessment report. Now, if there's any AWS branding people in the room, I apologize. We haven't updated the logo yet, but we're getting there. When this report has run, you can see it starts up at the top. We've got an executive summary. It tells you all the objects it found, what kind of conversion ratio you're going to expect. But the really fun stuff is when you scroll down and you have a look at some of these graphs. So this is saying if I targeted MySQL as an engine, I'm going to have pretty good conversion ratios for my sequences, for example. And you get a bit further down, and well, there's going to be some manual work for my procedures. And you get to compare it, of course, to Aurora MySQL. Go further down again, and Postgres, you can see that we've got slightly different conversion ratios, right? But that's actually not the schema I want to analyze. I want to have a look at Chinook. So we're going to do Chinook, hit next. All right, and you can see the Chinook schema, we're doing a little bit better on our conversions. Hit next again. And what it's asking me right now is which of those engines do I want to choose? I'm going to choose the Postgres engine and connect in with just, again, standard details. So this is, the name of the host up in the AWS cloud, username and password, and press finish. So once I've done that, we get into the IDE, which looks like so. right? So the idea being in here, I'm going to look at the Chinook schema, and I want to convert it. So I'm just going to right-click and go Convert Schema. It says, okay, there might already be something there, not a big deal. And once that's converted, what I can do is expand the objects. You can see I've converted those tables, packages, procedures, and so on. If I have a look at some of my tables, I'll just say click on the first one. What you can see at the top is what the table DDL looked like for Oracle, and at the bottom, what the equivalent Postgres DDL looks like. And you can go through and look at any object in here, and you can see that it's converted them all. Likewise, when you get into things like the views, you can see we've got another view here. Here's what the view looked like in Oracle. Here's what the view looks like in Postgres. All right, so I've now done a conversion. I'm going to be honest and say, for big databases, it's a much more complicated procedure, but the same general thing holds true with how you do it. I'm just going to go and apply it now to the target. So as I hit apply, two things are going to happen. It's going to apply the full schema for Chinook. So if I go back to my query tool and go to my Postgres instance, and I'll just do a refresh, you can see I now have this Chinook schema. So the Chinook schema is in here. There's all the tables. Notice there's a bit of a difference. They're all lowercase, but they've all been created inside my Aurora instance. But if I have a read of the data, you can see it's empty. So remember, step one is convert your schema. Step two is move your data. There's also something else that's been created automatically. This is the extension pack. It gets created on any target where we use SCT, and all it does is it mimics functions that are available in your source engine that aren't necessarily available in your target engine to make the conversions easier. So if we have a quick look at this, say go in and look at the procedures, here's a bunch of procedures that we've created in this library to make it easier to do the conversions. So, a good one to look at down here is a bunch of casts. So, tochar, for example. The tochar function in Oracle behaves differently than Postgres, so we've created essentially the equivalent in the Postgres target. All right, so to prevent an error during this migration, I'm going to tell you one thing that happens. Best practices for a migration is that you disable triggers and foreign key constraints during the full load. If you don't do that, some strange things can happen if you don't maintain consistency or in the order of the information that you move. So I have a quick script here to actually remove the constraints. So this is just, again, easy thing you can just find on the internet yourself if you want. But I'm going to run this. Make sure I'm against the right schema here. Oops. Thing against Chinook. All right, so what I'm going to happen here, I'm going to create this table. I'm going to run it. And then this little script here loops through my database schema and gets rid of all the constraints. So if I go back now and have a quick look at my Chinook schema, do a refresh, you'll see here I have this table called dropped foreign keys. And if you have a look in the table, it's just created scripts for every key that I've removed so that at the end, if I want, I can just rerun this and it'll recreate all the foreign key constraints in my database. Pretty straightforward. So now let's actually move some data. So AWS website, again, no magic here. I'm going to sign into my console. DMS is available in every region around the world right now. So you can pick your region. I'm operating out of Oregon, but totally up to you guys where you want to run it. And I'm going to go and click on DMS. So as I mentioned earlier, there's a replication instance. So this is that replication instance. In my case, I'm running on a C4 large. You can use either T2s or C4s. And just to save some time, I've pre-created all my endpoints. So these endpoints point to those same databases you saw listed in my query tool, but you can go create them yourself. The main idea here is you create a task. So I'm going to create a replication task, and we're going to call it, let's just call it Chinook. Which replication server do you want to use? Because of course you can have more than one. And we're going to move information from my Oracle source endpoint to my Aurora Postgres target endpoint. And again, these are just the endpoints that you saw on the last screen that were created. I'm looking to migrate the data. I want to start it on create, And I don't want to do anything to my tables because DMS can create tables for you, but it can't create triggers and procedures and what have you. So that's why it has that drop option in here. And I don't have any lobs in my database, so I'm just going to speed it up for time purposes here. All right, just want to make sure I'm not missing anything. All right, let's do some data validation too. This is a new feature that we've added, and I'm also going to turn on logging. Data validation just makes sure that the records got moved across without any issues. And logging, of course, if there is a problem, you want to be able to see what the problem is. So what do I want to move? I want to move my Chinook schema, all tables, the % sign is a wildcard, and I just want to include them. Remember, I mentioned it's a logical tool, so you can filter down and say, look, only some records I want to move if you want. And I need to add a couple transformation rules. Basically, everything in Oracle is uppercase, so I want to make sure that when I migrate things over to Postgres, I want to make everything lowercase. So let me just get this on my screen. I'm going to go here and make lowercase, add my transformation rule, so that's for the schema, and I'm also going to do it for the table. Technically speaking, you should do it for the column too, but I don't. The column only becomes important when you're actually replicating changes across, and there's no changes at this point, so I'm just going to skip that to save some time. So we're going to move things across, again, schema to lowercase and table to lowercase. Once that's done, I just hit create. The task is going to start creating, and then it'll start moving data. Now, when I did this, I did it this way to show you guys how you could create your task from scratch. There's actually some tight integrations between DMS and SCT. So because I'd already created my conversion, if you will, inside SCT, I could have actually created my DMS task automatically from SCT. So if I went back here, instead of doing everything that I just did there in DMS, I could have just right-clicked and said create DMS task. Right? So that option's there. I just wanted to show you how you would do it right from the console itself. So it takes a minute or two to get going. Eventually it'll kick off and you'll start getting some data in here. You can see now it says starting. And if I move this up just a touch and we go to table statistics, I'm going to have some screen real estate issues here, aren't I? Go down, I'm just going to hit a refresh. All right, it's not ready quite yet. Oh, there we go. So now you can see here's all the tables that we're migrating. It knows how many rows of data that we're moving across, and validation pending. So that's that validation option I enabled. So it knows, okay, I'm moving some data, but I still have 347 rows of data to validate that actually got moved across properly. But as that's running, what we can do, if we switch back to the database query tool, is if I go here and I read the data in the console, you can see I now have data in my Aurora Postgres target. So we've moved data from Oracle to Postgres using DMS. If I go back here, I might get lucky. There's the refresh button. And you can see actually that everything's been validated. So I've moved all my records across, except for 12. 12 more are yet to come. But basically the validations occurred, and what it does there is it looks at the primary key and makes sure that all of those columns of data are there, and row counts and what have you. So it's basically preventing you from having to do the validation yourself after the fact. So that's kind of the idea of what I wanted to show with respect to how a database migration happens. Create your schema, create a DMS task, move the data across, and away you go. Now, just to reiterate, your schema conversion is not always going to be totally straightforward. Rule of thumb, what we've found for if we take Oracle to Aurora Postgres as an example, we collect anonymous statistics behind the scenes. We tend to find that we get about 85% conversion ratio. Your mileage will vary. Some do better, some do worse, but we can certainly save a lot of time. And I need to press the button to flip back to this. All right, so best practices, things to consider when doing a migration. Various things to consider. Basically, first and obvious, you need to make sure that, we can do, like if we're talking native migration, in that case, you want to make sure you can do ongoing replication. You know, you can have access to those logs. You can pull the information across. You only do a native replication if you need to move all the data because you can't filter records with a replication. Dump restore, another great option, especially if you can take a downtime. Say you're doing a SQL Server to SQL Server migration. Yeah, you could use DMS, but you don't want to. The best thing to do there, if you can take a bit of downtime, is to take a back file export and then just dump it in an S3 bucket and RDS SQL can ingest it. Or you could combine methods. You could use that, and then you could use DMS to replicate across any changes that occurred during the time it took you to get that back file imported in. You're going to use AWS, DMS, and SCT when you're switching engines. But again, it's not your only solution, right? There's Aura to PG. That's a great tool out there to help you do your migrations if you prefer using that. But of course, you know, ours are always there to help. Other things to consider, if your data is so large you need to use a snowball, well, DMS handles this natively in conjunction with SCT. It's also important to realize that migration is a project. It's not a point and click, done in 5 minutes sort of thing. Based on our past experience, this is kind of where we see the breakdown of effort. And what you can see in there is your schema conversion and your data migration is actually not a huge percentage of your effort. Your big effort comes in when you have to do your testing. Definitely factor that in, right? Because it's one thing if I can do point, click, look, as you saw, I migrated my Chinook schema then and there, but I would want to test all the applications that are relying on that database to make sure things migrated properly. It's also important you understand your environment, your database. What do you know about it? I can tell you one of the most problematic areas we have during database migration are databases that have lobs in it. DMS does handle lobs, no problem there, but they're slow. Whoever thought it was a great idea to embed movies inside a database is just beyond me, but people do it. And you know, you just need to be aware of it, you need to know what's out there. Other things that can slow it down, you want to make sure you have primary indexes on all your tables. If you don't, well, and you're enabling change data capture, we're probably going to be doing full table scans to see, you know, what's changed, what needs inserting, and that's going to slow it down. Other things to consider, your network. You saw I managed to connect to my source and target databases quite easily. Well, I'm going to let you know that's because it's all inside my own VPC. Your network infrastructure is probably a lot more complicated than what I had set up there for a demo. You're going to have some sysadmin that probably wants to lock down every port left, right, and center. You know, maybe you've got to get a VPN set up or a direct connect connection going. These are all things that take time, and you need to make sure you factor it in when you're doing your migrations. And then, of course, there's bandwidth. If you're already running hot and, you know, utilizing 99% of your internet capacity for Facebook messages, you know, you just need to take these things into account when you're doing your migrations. So what affects speed? Size of the database, of course, it's the obvious thing. Bandwidth, yes, but it's also things like the structure of your database. If you have a terabyte database and your neighbor has a terabyte database, but his has tables evenly dispersed making up that terabyte, it's going to move a lot faster than you if you have one database or one table that's 900 megabytes, or 900 gigabytes rather, and a few other tables that make up that last few gigs, right? So very big tables will slow things down versus an evenly dispersed database. Of course, you know, how much power you put behind things. The bigger instance size you can give, the better. In fact, even though some of the C4s cost a lot more than a T2 for DMS, they'll finish so much faster it'll actually be cheaper. Other things, find the right people. If your people don't understand databases, you might have some trouble. Make sure you start small, do a point of concept, or proof of concept rather, and then also make sure you read. We've got lots of good blogs out there, and we've recently released something that has a nifty name known as a cookbook on our website that gives you step-by-step things to consider when doing a migration, especially from Oracle to Postgres. So these are things to look at. Now with that, I'm going to hand over to Kevin to finish off a few more best practices that we've come across in our time.
Great. Thanks, John. That was awesome. Some other best practices, these come from a specific large customer I've been working with who has about 5,000 Oracle databases to migrate. And so they've decided to migrate all of them off to Postgres, either RDS for Postgres or Aurora Postgres. And so these are some of their best practices they're putting together as they go through this massive project. One of the things is as you can see here, keep backups disabled, just so that the migrations can go faster. They also have discovered that it makes sense to have a separate parameter group. And this is an RDS concept where you can create parameter groups with database configuration parameters. They suggest having a separate group for each instance because they found they need to tune each instance differently in the landing zone. And then they also, kind of early on, this is sort of referenced in John's previous slide, they used SCT kind of en masse. They started with 1,000 databases, ran SCT against all 1,000 of them, and looked at the assessment reports to classify their databases into easy, medium, and hard, because they wanted to start with the easy ones and build up their confidence and their experience and their abilities and their momentum and move on from there. So if you have a large number of databases, it's really useful to use SCT just to be methodical about your migrations. John covered this. There's stuff built into SCT and DMS to handle this. But by default, Oracle does everything in uppercase and Postgres does everything in lowercase. And so you've got to make sure you do the conversions right, whether you're using DMS and SCT or other tools. Otherwise, you're going to get very confused when you move to Postgres. And so some other best practices in terms of planning your cutover. John mentioned some of this as well. You want to make sure that you disable things at the right time, disable triggers, and then re-enable them at the right time. Make sure you're planning to turn on or rebuild your foreign keys at the right time. Think through what your validation steps will be, both before you cut over and after, and make sure you have a rollback strategy. You need to make sure that, you think everything's going to be great in your Postgres target. Maybe you got something wrong. Maybe you missed something despite your validation steps. You need to make sure you know how to fall back if you have to. And then there's specific extensions that are specific to Postgres, available in both RDS Postgres and Aurora Postgres, that let you do things like use SQL to look at your Postgres logs. That's the log FTW extension. PG Repack helps reclaim space in tables. And PG Audit actually implements auditing at a level that some of our financial services customers say is sufficient for their auditors. So these are extensions that are really useful just post-migration to help you make your environments more capable and more compliant. All right, so we have a few minutes for questions.